Thanks for joining this session today on APMs, profilers, static analyzers, and trying to figure out, in a couple of words, again, this session isn't going to be very long, who's who. So what can you get out of such tools? I'm Christophe Dujarric, and I'm Chief Product Officer at Blackfire.io. You can follow me on Twitter or send me messages. I'm more than happy to answer and help you out. Throughout this presentation, I have inserted some QR codes like the one you see on the screen here. They point to additional documentation so that you can review that later on if you want to dig further. So yeah, I will always try to give you enough time to take your phone and flash the code. But again, also at the end of the session, if you have more questions, if you want the links, I can provide them to you. I'll be happy about it. So in my session, we're going to browse through why is it interesting to even just use any of the tools that we have listed. And then we will go and see what is a debug tool, what is a static analyzer, what is an APM, what is a profiler, and try and understand what are the various benefits, strengths, and weaknesses of each of those tools. Overall, it really is a matter of dealing with quality, security, and performance of the code. So our target here, us all, is to provide a tool, a service, maybe an e-commerce shop, you name it. We are here to create something for an end user, right? It's not it. Well, usually people don't code just for coding; they code to solve a problem. And of course, if by providing such a solution we create more problems because there is very slow application or because there is many bugs, then we actually don't solve anything, right? We're not providing an actual viable solution. And therefore, that's why it's so important to also, on a day-to-day basis, make sure that whatever we develop actually works properly as expected. And such tools are here to help us do that as proactively as possible, right? As much as you can, of course, have tools that look at production and tell you when something is going wrong, and this is, of course, something that you need, it's much more powerful if you can deal with such errors, if you can avoid such errors from ever reaching production. And of course, it's even more powerful when you can do that on the local development machine, because you're just all alone on your machine, right? You don't have to interfere with the rest of the team. You can iterate very quickly, and that's all about having great developer experience. So do that while you develop, and be very quick on iterating. So that's one of the key points of debug tools. Actually, in debug tools, you can name Ray, you can name the Laravel debug bar, or even more raw tools like dump or var dump. There are tools such as Xdebug. All of them assist developers with contextual information on code behavior while they develop. So they can provide variable values, object states, etc. They're really close to the code. It's even possible to add breakpoints so that when you are executing some code, the debug tool is going to say, okay, stop here and let's have a look at a very specific state of the code. And they have this great capacity of being able to integrate with IDEs so that you have everything within your development environment. You don't have context switch or anything that would basically kill your thinking and developing process. However, such tools sometimes can be very complex to get up and running. This is something that we hear a lot, for instance, from Xdebug. It looks like Ray is not facing such issues, but then is very focused on Laravel. They do also PHP in general, but it seems that the experience is especially improved for Laravel. And anyhow, it's something that, well, a debug tool is usually not something that you should use in production because it can slow down the code a lot because of the instrumentation very often, and it can even create real serious security issues. So as much as, yes, you can probably use some of it in production, it's probably also a good idea to avoid it. Then there are static analyzers. So amongst the static analyzers, most of the well-known ones are including SonarQube, that also can rely on things such as PHP Stan, Whoops, PHP Mess Detector, PHP Line of Code. Symfony Insight is a great one. Although it's named Symfony Insight, it's not necessarily actually usable only for Symfony. By the way, you can really try it out on the Laravel code base and find it very useful. The point of such tools is to automate some code review to detect common flows and mistakes by scanning a code repository. So that's a great thing. You just have your code repository, you get your static analyzer to read through the code and detect potential flows like those here that we can see on the screenshot. Those can be integrated in continuous integration pipelines. So if you already have some sort of a testing pipeline, maybe Jenkins, Travis, GitHub Actions, you name it, that's usually the good part where, before or after merging some code, you can get the static analyzer to run through it. It's often better, to do that at the branch level, as it can discriminate exactly, which part of the code you have changed that introduced a regression or a new error. But again, this is also something that is just going to work in development, right? As the name is, it's a static analyzer. It analyzes code statically. It's also limited to a list of control points so that you won't have any serendipity, right? Serendipity being finding what you're not looking for. You as a developer, obviously, the point of such a tool is to let you figure out things that you didn't think about, but the tool will still have the same list of control points, right? You won't go into the unknown of a tool that shows you everything that happens in the code and maybe things that the tool itself didn't even think about, right? And finally, one of the drawbacks of such a tool can be that some of them require you to upload your source code to an external server. For some applications, and some businesses, that's not an issue. They don't have any problem with doing that. For some other businesses, I have seen that a lot in the past, that they are just not comfortable with uploading code to a SaaS because they don't feel confident in safeguard the tool safeguarding their intellectual property. Now we go to application performance monitoring. So overall, usually the brands you will have heard of are New Relics, AppDynamics, and we are now actually also running a beta of our own APM. So application performance monitoring, what does that do? That's all about supervising traffic to an application that is deployed in production. So basically traffic from real end users to a web application. Of course, it's also something that you can use on staging, and staging some tests with some load testing and such. But one of the main benefits of an application performance monitoring tool is to get data from the live environment with real context, right? With users doing things that you didn't expect could be done even, or that they would do usually. And that's where, the monitoring tool is going to tell you exactly how the performance is perceived from the end user perspective. However, the level of information that an application performance monitoring tool will give you is somewhat limited because of what we call the overhead. I will get to more details about what the overhead is and how it can actually impact or not an application and an end user. But the point is, as soon as you start monitoring, as you start measuring the performance of some code, you execute more code. So there will be an overhead. And the deeper you go into acquiring metrics about the code's execution, the higher the overhead will be. So the point of an APM being to monitor the real end user traffic that comes to the site, the overhead must be very limited. Basically, you just want to avoid killing performance because of a tool that is actually here to help you improve performance. That's where also Profiler can come in and be quite orthogonal to an APM. There are some legacy profilers on the market, so there is even a really venerable tool such as XXProf, which back then was created and open sourced by Facebook. Xdebug is not exactly a legacy profiler. To be fair, I'm listing it as such as there is quite some points that Xdebug does and does well, but we found other ways of doing it, and especially by using Blackfire instead of Xdebug, you can actually use Blackfire on a production site. This is something you should never do with Xdebug, right? But Blackfire Profiler can be used in production. The whole point of a profiler is to get function call level metrics. So from the very core of PHP, Blackfire is some sort of a stopwatch that will tell you, okay, here we started to execute a function call, there we ended this execution. It will also give you the full relationship between callers and callees, so which function call called which one, and then you can view call graphs such as the one you see here on the screen. It can give you a lot of information on SQL queries and basically break down the the resources consumption of the code on the server. So usually you would talk about time and memory. This is the basic concepts of performance. When you want to improve performance, you want to improve time. And basically memory is also related to time. The more memory you have, the more time you will need to handle it. So it always goes back to time at the end of the day. Now, time can also be broken down when you talk about PHP in different dimensions, including the wall time, which is the overall PHP execution time, the input-output, which is the time spent waiting for memory access, network calls, anything that goes out or in. Then there's the CPU time, so that's the time that the CPU is actually going to execute some code. And then you can break down even more with memory usage, network calls, HTTP requests, SQL queries. So this is the kind of information that a profiler will be able to give you at function call level. And as I mentioned, the main difference between tools such as Blackfire and Xdebug is that Xdebug cannot be used in production, whereas Blackfire is built to be used in production on a development machine and integrated into any continuous integration, continuous deployment, any sort of testing pipeline where you will be able to automate profiling and get reports that will tell you if your application and your code matches the performance budget that you can define at the very beginning. Still, one of the main flaws of a profiler is that it does not detect which URL is slow, right? So that's the role of the APM. The APM looks at the whole traffic, and then at a high level, it's going to tell you, okay, well, we see the performance going up or down for this part of the code, but then the APM doesn't tell you why it's going up or down. That's the point of a profiler. The profiler doesn't tell you which part of the application is going is degrading or is improving, but then it can tell you exactly why it is degrading or improving. And yeah, as you can imagine, that's the point of us now releasing that beta of the APM. By combining an APM and a profiler, you get the best of the two worlds. A final note on overhead, because this is a question that we get very often. As soon as you start using a measurement tool on production, there is a matter of overhead. It's inevitable. If you have some code that runs for your application and that you run another piece of code that is going to analyze your application at the same time, obviously you are using server resources at the same time. And some tools, you can run on another server and they will just have a very exterior point of view. And the good part is that by then they actually do not add an overhead. But of course, that also means that they won't tell you anything on the internals of your code. So as soon as you want to know what's going on internally, you have to run the code on the same server, and therefore you create the overhead. Now, what's important, of course, also is that the overhead should happen only when you actually measure something. And this is exactly what we worked on with Blackfire. You can install Blackfire on a production server and have no overhead at all, as long as you don't specifically say, I want to profile this part of the code. And only for that very single request that you will trigger for profiling purposes, you will have the Blackfire overhead. So it will actually never impact end users. Another question that we often get is also, why do I have, when I profile with Blackfire, it tells me that my code executes in, 2-3 seconds. Whereas if I look with some other tools, so maybe just an APM on production, it will tell me that the same code is actually executed in a couple of hundreds of milliseconds. The point is, overhead always will depend on code complexity. It will, of course, also depend on the power of your machine. So comparing a measurement on production and a measurement on development is not going to be so relevant, because obviously your local machine is not going to be as powerful as a production machine. But anyhow, the code complexity is going to impact it. So in the overhead, there's a linear part, and then there's also a static part. So for each function, there will be a static value of overhead. So the more function calls that are executed in your code, the more SQL queries that you have in the code, the higher the overhead will be. Which is, of course, something you should look for. And at the same time, it's not so much of a problem. As long as the overhead is stable, what matters is to look at relative values rather than absolute time values. The first point you need to understand is that time is just a consequence of what happened in the code. So actually, yes, we always will try to improve time. This is what I mentioned at the beginning of the session. But in order to improve time, we shouldn't look for time metrics. We should look for poor code behavior. This is the patterns that we should be looking for. Why is such part of the code slower than the rest? And that's the point. Why is it slower? Not slow, but why is it slower than the rest? If you improve the slower parts, then obviously all of the code will become faster. So you will reach your objective of making code faster. Yeah, so that wraps it up. I hope this helps and this clarified a bit the various tools that you can use to improve code quality, code security, and code performance in general. Again, I'm happy to answer any question at the end of the session or later on via Twitter or via our support site on Blackfire.io. Thanks a lot.